Good to go. Yep, there goes.
Okay, great. Well, hello, everyone. We're going to get started now. Welcome to our webinar, Creating a Level Playing Field for Battery Energy Storage Systems, brought to you by the Climate Economic Analysis for Development, Investment, and Resilience, or CEDAR activity, brought to you by the financed by the U.S. Agency for International Development. I want to give thanks to the USAID Sharing Environment and Energy Knowledge, or SEEK project, for their support in hosting today's webinar platform. Next slide. My name is Pablo Torres with Crown Agents USA. I'm CEDAR's Chief of Party, and I've been with CEDAR since July of 2015. CEDAR is a $20 million activity that helps governments, the private sector, and civil society make the business and economic case for climate change mitigation and adaptation actions, and that helps to accelerate public and private financing for clean energy, sustainable landscapes, and adaptation. Next slide. So today we're going to present CEDAR's study, Creating a Level Playing Field for Battery Energy Storage Systems Through Policies, Regulation, and Renewable Energy Auctions, which is publicly available on the USAID DEC website, to which a link is provided at the end of the presentation. I'm going to introduce the study purpose, methods, contents, and then we'll have the pleasure of hearing from three excellent panelists. Andrew Feng from the USAID Energy and Infrastructure Office will provide an overview of battery energy storage systems, or BESS, discussing why storage is important, what services it provides, and the types of storage, and some drivers for BESS market penetration. Then CEDAR's Patrick Doyle will discuss the U.S. federal policy and regulatory enabling environment for BESS, and dive into some of the U.S. states that are leading the way in BESS deployment. And the purpose of that research in the U.S. was to help inform BESS market development in developing countries. We will then turn to CEDAR's Luis Maurer for discussing BESS in the context of renewable energy auctions, with a special interest, of course, in developing countries. And he'll talk about topics such as auction qualification and bidding requirements, domestic content requirements, award criteria, business models for BESS, etc. And I will conclude with the study's findings and recommendations and moderate the Q&A. So we're going to present for about 40 minutes, and then we'll have time for a Q&A session. Please submit your questions for the panelists through the chat window of the platform as we go along, and I will pose as many of them as possible at the end. And as a reminder to those of you who just joined us, please turn off your video. Thank you very much. Next slide. So USAID asked CEDAR to analyze the impacts of the policy and regulatory environment and the design and implementation of renewable energy auctions on the creation of competitively leveled playing field for utility scale BESS investments. The purpose of this report is to help government, policymakers, regulators, utilities, and developers in developing countries facilitate private investment in battery energy storage systems that are financially and economically viable. This report draws on experiences in the United States, including with utilities such as Hawaiian Electric Company and Xcel Energy, other developed countries in Europe and Australia, for example, and developing countries such as Chile and Thailand. For this study, CEDAR interviewed 16 renewable energy auction participants, including some that resulted in awards for BESS, and representatives from 12 other organizations. Next slide. So the study report contains a wealth of information, more than we can cover today, starting with background information on the importance of BESS, the types of storage, benefits, and services, for example. It then discusses the enabling policy and regulatory environment for BESS to gain market penetration based on context from the US and other developed countries. The report then dives into BESS in the context of renewable energy auctions and other competitive procurements, and discusses how many aspects of those procurements affect the participation of BESS in a competitively level way. And the study concludes with findings and recommendations. Now, before I turn it over to Andrew, let me just say one last thing, which is that, should there be any terms you're unfamiliar with during the webinar, and there are some technical terms, you can turn to the report for an extensive glossary of terms. So with that, welcome, Andrew. Take it away.
Thank you, Pablo. Good morning, everyone. As Pablo mentioned, I'm Andrew Feng. I'm with the Office of Energy and Infrastructure with USAID Washington, and I'll be giving a brief overview of battery storage issues, and then turning it over to Patrick and Louise. Currently, I'm a AAAS Science and Technology Policy Fellow with the Office of Energy and Infrastructure, and my current portfolio is really focused on USAID's NREL partnership, looking at emerging technologies, both in terms of battery storage, electric vehicles, and more broadly, distributed energy resources in general. My background is I have a PhD in public affairs, mainly focused on urban sustainability issues related to low carbon development in cities in India, China, and the US. Next slide, please. So to start off with, I thought we would just talk about sort of what the role of batteries are in the grid, and sort of what growing role they might have. I mean, I think we all know the power sector is becoming more decentralized, more digitalized, and there's a energy transition underway, both in developed and developing countries. I think as we have all these new generation assets, these new decentralized assets coming on board, we still have to make sure the grid is able to fulfill its main role of, making sure that the electricity demand is met by generation assets throughout the year and that the grid is reliable. So batteries can fill a variety of roles in sort of grid management, which I've shown in this figure here from the DOE. In the red circle, you'll see different grid management services that batteries could potentially fulfill, from left to right, looking at behind the meter applications in blue, and then looking at market applications in green. So I think today we'll focus mainly on batteries' ability to manage load at the seconds, minutes to hour intervals. And so you'll see batteries able to fulfill a variety of roles in frequency regulation, energy arbitrage, reserve capacity, and other grid management issues. Next slide, please. So just to start off with, when we define BESS, we're really only talking about lithium-ion batteries at this point. And mainly commercially, the lithium-ion batteries on the market are looking at short-term energy storage with duration of 4 hours or less. So there are a variety of energy storage technologies you'll hear about. And I guess I just encourage the audience to think about, when they look at each of these technologies, both the capacity or the power that these technologies could provide on the grid, as well as the time interval at which they could provide this capacity. So on the y-axis, on the graph on the right, you have different technologies sort of distributed based on their capacity on the y-axis and their discharge duration, or the amount of time they could provide that power on the x-axis. I guess I'd highlight sort of potential technologies for longer duration storage, more than 4 hours. More conventional technologies like pump storage and compressed air, sort of limited in their geographic availability. Whereas hydrogen and flow batteries, I think you hear a lot about sort of in the news at the pilot scale, but none of those technologies are commercially available, but are potentially game changers for energy storage in terms of storing energy longer than 4 hours. Next slide, please. So one of the reasons we're really interested in storage is sort of the applications it has for helping to integrate more renewable energy into the grid. So here you'll see the infamous duck curve from California, which essentially looks at load, electricity load or electricity demand throughout the day. And normally you'd see this peaking around, between 12 and 4 p.m. during the day. But as more renewable assets come online, you might see this shape of this curve essentially change. And so what batteries can do is they can store energy from renewable energy assets when there's not as much demand, and then release that energy when there's peak demand after 4 p.m. along this curve. And so essentially you'll smooth the load curve, reduce the cost generation, as well as help with the other generation assets to manage load throughout the day. Next slide, please. And so I think a lot of what you hear in the news is sort of this exponential growth of energy storage. And I just wanted to talk briefly about sort of why we see that exponential growth. The cost of storage has gone down by approximately 80% over the last 8 years. So it's becoming more and more cost competitive for a lot of these ancillary services and grid management issues that I described previously. I think we're still projecting an additional 50% decline in the next 5 years on battery costs. Currently, they're projecting $100 per kilowatt hour cost of storage by 2023. And so what you'll see is as these batteries become more cost competitive, there'll be more and more commercial applications, both for integrating renewable energy, as well as participating in a variety of energy or grid management markets. Currently, I'd say ancillary services are where batteries are mainly participating in. But as Patrick and Louise will talk about, there's a lot of opportunities for batteries to participate in more grid management services moving forward as the cost comes down. Next slide. And then I just wanted to finish by talking about sort of where USAID is engaging in the battery storage or the BESS area. Louise will talk a little bit more about renewable energy auctions, but we are thinking about batteries in terms of their ability to provide reserve capacity for some of the competitive procurement and renewable energy auctions work that we're doing through the Scaling Up Renewable Energy activity, which is housed out of the Energy Division at USAID. And we just started the second iteration of that activity in October. I'm more familiar with the second bullet point, which is the USAID NREL partnership, which we are creating a new energy storage toolkit, which should be online in the next few months. But that toolkit will both look at utility scale battery storage issues, which we'll focus on today, which is the first link I've shown there. And then we've also been looking at behind the meter storage issues related to PV plus storage, especially in India. And so we'll continue that work moving forward. And then I just mentioned, as Sarah Dimson mentioned in the chat, that Power Africa has a new Recharge newsletter and a variety of energy storage resources and information available to USAID colleagues. So there's a variety of different ways to engage in storage if you're interested in moving forward. And I will now pass it on to Patrick to talk about policy and regulatory issues and stuff. Thanks.
Hi, my name is Patrick Doyle. I work on the implementation side of battery energy storage systems, mainly on utility scale systems to date. Previously, I worked implementing demand side management programs for utilities. There's some similar characteristics between the process you go through to get demand side management approved versus getting BESS approved and moving forward. I've also worked for energy service companies that worked under the energy savings, ESPC energy savings performance contracting program that was run by the Department of Energy. Today, what I want to talk about is from the developer perspective, basically the EPCs, the engineering, procurement, construction companies. Basically, they go where the opportunities are and where the projects are. And the focus that I have is on the United States market. We're hoping that some of the lessons learned or some of the things you've learned will help developing countries and how to proceed with getting BESS implemented in their countries. Basically, we go from starting with the federal changes that have occurred to the state level and how they change things. And so the first major change at the federal level, the traditional power system was basically a centralized power system run by investor-owned and other utilities. They own the generation. Generation went to the consumers, the commercial, industrial, residential customers, and it was basically a one-way flow. So it was an easy system to plan for and manage. Over the past several years, maybe more than that, renewable energy has come on the market that basically produces a two-way flow of electricity. And BESS is now one of the latest technologies that have come on, and it makes for a more complicated system for the utilities to manage. So the commission needed to create a level playing field, if you will, because BESS provides a positive benefit, whether it's consuming energy or producing energy, and needs to be compensated or rewarded for providing that. So FERC Order 841 basically changed the rules, and it allowed BESS to equitably participate in the wholesale market, removing barriers to entry. And now that has been kind of approved to go forward, and basically has opened the market for BESS, especially the utility scale. Next slide. So in the States, basically, there's been kind of a process as you look back to see that's unfolded. First, at the legislative level, a renewable energy, clean energy goal, our portfolio standard target is established. And right now, there's about 25 states that have done that. The next step, I think, is the most crucial, is at the regulatory stage. Once that goal is passed at the legislative area, either by the government, the governor of the state, then it's up to the regulators to take the next step and put that into goals or targets for the utilities to work towards. So the utilities also, as many of you are probably familiar, they have to do IRPs, or integrated resource planning. Typically, those are for looking out 10 years, and they're updated every 2 or 3 years. And what's happened is, as new technologies like BESS have become more cost effective, they've been able to incorporate requirements for the utilities to implement BESS as part of their supply side going forward. So the perspective I come from, as I said, the engineering, procurement, and construction companies that basically are building the utility scale BESS projects, which are the ones that the utilities are kind of putting out to bid and managing. So the EPCs, like I said, they go where the opportunities are. And right now we see those opportunities, not to mean that there's not stuff going on in other states, but the main focus of EPCs to date has been in California, Texas, Nevada, Arizona, and I suspect Oregon will be soon, as they've recently come out with a mandate for state utilities to incorporate BESS. Next slide, please. So again, these are some of the goals that have been developed for California, Nevada, Arizona, and Oregon. These have been published and basically approved to move forward. There is a goal of 7.3 gigawatts, or excuse me, a forecast by Wood Mackenzie. 2020 was supposed to be a very good year for BESS implementation. There are a lot of projects under contract, but a lot of those have been delayed for a couple of reasons. In California, they've had the wildfires, as many of you know. There's also been fires at 2 facilities, large facilities. One was in South Korea and one was in Arizona. I'm talking about on the BESS project itself. The project was built and implemented, and there was a serious fire condition. So basically, projects were put on hold until there was a detailed study of what caused the problem. And then that's been done, and there's now a correction put in place so that that doesn't happen again. Next slide, please. So we're going to look specifically at California and what were the market drivers, and these are similar to other states, if you will. First, they set a pretty aggressive goal for their renewable energy goals and their clean energy goals. But I think most importantly for BESS is the levelized cost of energy from lithium-ion batteries has decreased significantly. It's just made the, excuse me, it's made BESS a cost-effective option versus peak power. So previously, a utility, excuse me, I just need a drink. Previously, a utility that needed to add peak power would build a combustion turbine and put that, either at a substation area or near a main generating plant. And with BESS, that's now become more cost effective to do BESS. So the IRPs I mentioned earlier now incorporate BESS as the alternative for our combustion turbine. Also in California, another driver, there was an excessive heat wave this summer that lasted significantly longer than anticipated. It made the peak longer during each day. And it basically, the utilities were caught short on power in their planning. In California, they used to import, or they do import power from Arizona and Nevada, and they had similar heat waves, so power wasn't available. So they had to go to rolling blackouts. And then the wildfires, there was, again, a rolling blackouts for safety reasons. So the bottom line is utilities, which typically like to, say that their power is available 99.99% of the time. Unfortunately for residents of California, that was true this year. So there has to be some changes to make that, make power more available and not have these rolling blackouts. Next slide. So the first step in the California market, as I said, were the utility scale projects. These were the ones initiated by the utilities. One of the EPCs that we work with, they've got approximately 2,700 megawatts of BESS that they expect to be online by 2024. So the utility scale market has been developed and it's moving significantly. But there are also a number of new approaches, and I think this is a result of the wildfires, the outages that were caused by lack of power, sufficient power. And some of these new approaches, the city of Gonzales, California, has contracted with an EPC basically to build a microgrid. I think it's about a 35 megawatt microgrid to serve the city. So what this will allow the city to do is if there's a power shortage, they can, when they put in the microgrid, you can either buy power when it's more cost effective from the utility, or you can switch to your microgrid if the utility is going to be shutting off the power to keep, the government agencies, hospitals, police, whatever that needs to rely on power to be going 24/7. There's also what's called community battery energy storage projects being developed. There was some time when renewable energy, solar power began community programs where they signed up different and aggregated these customers together who were interested in the solar project but didn't have the right orientation or whatever. So they started these community battery energy storage that is similar to solar. Also, there's a behind the meter self-generation incentive program that was developed so customers can start on their own and do their own battery energy storage and put these in. And then new technologies. Part of this is because of the fires that I mentioned that for safety, but also the flow batteries, the technology supports longer life, if you will, for the battery energy storage system to be on during peak times. And then lastly, it's not a new development, but I mentioned the Tesla Megapack. It's one of the largest battery energy storage systems that have been installed in the country. One EPC that we work with, they believe Tesla will begin in the next maybe 5 to 10 years, will dominate the battery energy storage market for these large systems going in. So what we try to do is provide a perspective on the U.S. market and what's made utility scale and now some of these other initiatives successful. So with that, I'll turn it over to Louise Mara, who'll talk about how we incorporate BESS into the energy auctions. Louise.
Thanks, Patrick. This is a nice segue into my speech. I will be addressing the issue of how to procure BESS and BESS-related portfolios in a competitive scenario, under different competitive scenarios, leveraging on the experience of renewables, with the primary goal of expanding renewable penetration even further. My name is Luis Maurer. I'm now an independent consultant with about 40 years of experience. I'm a retiree from the World Bank. Prior to that, I worked for Enron, Coopers & Lybrand, Booz Allen & Hamilton, and for the utility sector. My areas of expertise include power sector reform and the procurement of competitive resources for the utility sector, particularly through auctions. I am an electrical engineer with an MBA from UCLA. Next, please. So let's look first on what has happened in the auctions for variable energy resources, even before batteries came into play. Auctions have proved to have a solid track record for efficient procurement of renewable resources. I think that now, according to IRENA, more than 100 countries have adopted auctions for renewables compared to maybe 10 years ago. 10 years ago, feed-in tariff was the primary mechanism for procuring renewable resources. And the reason is very simple. The auctions provide efficient price discovery. They help transfer cost savings to the end user. And in case of dynamic price auctions, they reduce the winner's curse. It's the tendency to underbid. And this issue was extensively analyzed by two of the Nobel Prize recipients this year, economic Nobel Prize recipients, Milgram and Wilson. And the auctions, as a result of an auction, the product being auctioned is a long-term purchase agreement which facilitates bank loans and equity investments. Also, we hope that also auctions will be very useful for hybrid renewable resources combined with batteries. Batteries, I mean storage in general, but in particular batteries. We don't have a lot of experience. I think we are able to collect examples in the last 2 years. Some of them interesting ones are India, Thailand, the US, as Patrick mentioned, Chile, Australia. And the business models are still in state of flux. Every day we learn about different experiments, new countries trying different models for combining renewables with BESS. One of the challenges is how to obtain how to maximize compensation for the full range of benefits that that BESS can provide. What we call value stacking. They don't provide one benefit only, maybe 10 or 15, some of them for BESS behind the meter and some of them for BESS in front of the meter. We'll be focusing on BESS in front of the meter only. And most of the renewable auctions are designed for one product, megawatt or megawatt hour. Now we have a much bigger challenge. We have to auction multiple products, and if we auction just one product, the owner of those assets, they have to try to monetize those values in the market. But in many of our client countries, there are no markets, or the markets are very limited for ancillary service and capacity services and other services that BESS can provide. So the challenge remains. Next one, please. Well, similarly to renewable auctions, the power purchase agreement continues to be a pillar for the success of combination of hybrid, renewable, and BESS. We can think about merchant batteries, but for the time being, for our client countries, this is still something yet to be proved and requires very sophisticated markets where arbitrage possibilities are feasible. So for practical purposes, the PPAs are contracts that specify the products and services being traded, pricing, obligation, and the time period. They are complex. Normally, they are complex documents with detailed terms and conditions. And introducing BESS adds one additional layer of complexity. We may have different types of contracts, such as BESS as a standalone resource in combination of variable generation, and even as part of technology neutral solutions, where thermal generation is also included. Next one, please. So let's first talk about the auction qualification and bidding requirements. I think a very important distinction is there are two major groups of competitive biddings. One is where the results or the award is solely based on price. The pre-qualification is a kind of pass or fail requirement. And for those qualified bidders, they submit financial bids. And it's very suitable for when the product is very well understood, it's very homogeneous, and the standard contract requires little negotiation. Once it's done, it's done. Most of the successful renewable auctions have been based on price only. And that's what economists call auctions per se. The system is flexible to accommodate new auction designs, such as reverse auctions, to increase competition and further reduce prices. In a dynamic auction, you can bid several times. There are several rounds of price bidding, and there is a price discovery throughout the process, which enables bidders to know more about the common value of the product being traded. Therefore, they become more aggressive. They are less fearful of what we call winner's curse, which we'll discuss after. And the second group is where the auctions are based on price and non-price factors. And the award takes into account a weighted average between those two factors. Typically, the price is one shot. It's a written bid in a sealed envelope. And the award, as I said, is based on an average factor for identified winners. It's suitable when the products and services are not clearly defined and the auctioneer or the utility procuring those resources wants to have innovative solutions. It's more complex and costly to administer. The jury is still out. We spend a lot of time debating which model is better. I think it depends. What we have seen is that in the corporate world, many companies are moving through to auctions only, like Google. Google now runs a reverse auction, and they're very happy. And we have seen countries like France moving from price and non-price factors to price only, such as auctions for offshore wind resources. But we don't have a clear view. I think it's very situation specific and very regulatory driven. Next one, please. The issue of domestic content requirements has been an important issue for renewable resources. Some countries have included several requirements, such as minimum share of equipment cost produced domestically, bid price adjustments, evaluation preferences, eligibility for special lines of credit, award quotas, and you name it. In some cases, the requirements are softer, such as a necessity of training local people and workers, particularly in operation and maintenance, and the inclusion of domestic EPC firms. The rationale is clear. It's to improve the balance of payments, create local jobs, develop technology, and increase EPC local capacity. The disadvantage is that it may increase costs and reduce competition. In the BESS world, we don't have experience yet about domestic content requirements. But what we can say is that the production of batteries and the integration between batteries and the rest of the system is still a capital intensive and knowledge intensive thing that countries should not expect to develop overnight. So they have to take into account economies of scale and be realistic about expectations on domestic content requirements. Next one, please. So I mentioned before there are different designs, different situations, and therefore there are different award criteria and payouts for combinations of renewable and BESS auctions. Those are just examples, selected examples. This is not meant to be comprehensive. And as I said before, every day we learn about new models. Let's start with a relatively simple one, where the bid is for installed capacity. So the payment is for megawatt times megawatt of firm capacity. This is the state of Roraima in Brazil, where energy has to be delivered on a 24/7 basis. In Australia, which is an energy-only market, the auctions are based on the lowest cost per megawatt, and the payout is this lowest cost times the megawatt hour delivered. There are situations in renewable auctions where there are some price adjustments depending on the nodal factor. The initial auctions in Mexico promoted this kind of adjustment. What we have seen a lot is auctions for energy delivered during peak hour, or when situations where energy is critical, such as capacity auctions, where you have the case of India in particular, you have the auction for the lowest bid for megawatt hour delivered during peak, and megawatt hour during off peak is priced at a fixed feed-in tariff. So that's the Indian model. India is migrating toward around the clock auction, but this was the first one. We have situations where countries specify different prices for time blocks, which is the case of Chile. And there is an obligation to deliver a certain quantity of energy for each time block. And the bidder has to procure the shortfalls in the spot market to honor the contracts. And we have seen interesting examples in the US where the power generated megawatt hour and is priced at $1 per megawatt hour, and the storage is priced on a capacity basis. But you see, there are still so many examples going on. It's a continued learning process. We are learning as we go. Next one, please. As part of this study, we identified two important findings. One is that there is a trend of pushing different kinds of risks from buyers to sellers. So this is a kind of gradual movement towards, from left to right, gradual movement towards this risk shifting. And I'm talking about two particular risks: variability or intermittency, curtailment, which is the ability of the system to use this energy, otherwise it has to be curtailed. And the issue is who bears the cost of curtailment, and the market risk, which is the risk, what happens if the market does not need this energy. Initially, in the first renewable auctions, we had this concept of deemed generation, which was a very generous way of procuring. And the rationale was to foster the development of a nascent industry. There was basically, the seller had no risks, the project were very bankable, and the other rationale is that we knew little about the availability of those resources, particularly wind. Then we moved gradually to actual generation. the megawatt hour actually produced. So the curtailment risk now remains with the seller. Pay as contracted. Some countries like Colombia and Brazil have moved to this contractual arrangement. There is a contractual arrangement, and the difference have to be settled at market prices. So the variability risk now is gradually shifted to the seller. Time differentiated blocks in Chile. Now there is a more granular way of defining the time intervals. So there is a variability risk, higher variability risk imposed on risk and curtailment risk imposed on the sellers. And then on the last two columns, you have situations where the auctioneer wants to have quasi-firm and firm energy. And energy is very critical, particularly for isolated systems or in countries where the energy is not reliable at all. And the auctioneer or the ISO or the utility wants to have dispatchability. And dispatchability may be a 24/7 basis or maybe during peak and off-peak periods. As we move towards the left-hand side, we see that batteries or storage in general becomes more viable, becomes more necessary. Next, please. So in this study, we came up with seven business models for BESS in auctions. Not only with renewables, but in general. And let me make a disclaimer. This is not to be a comprehensive list. There are some limitations on those business models. One is that we are dealing with shallow storage. We are dealing with hours of storage, 2, 4, 6. And it basically relies on an existing technology. Technology of choice today is lithium ion. I'm not saying that's going to be in the future. There are other technologies in the pipeline. But for the purpose of this analysis, which is based on empirical cases, that's the assumption we used. And we are not taking into account business models behind the meter, which are very important, but we are not looking here. We're looking at only front of the meter business models. So you can see the range varies a lot from batteries as a standalone resource. We have only batteries, nothing else, up to situations where battery is combined with renewables or non-renewable resources to deliver firm power. In between, we have a full range of possibilities. One is value stacking services. We have seen countries, utilities in particular, not so much ISOs, because ISOs are more limited on what they can do in the system, but we have seen utilities such as Eskom in South Africa or Terna in Italy. They either own the resources or they contract resources, BESS resources from third parties, and they decide how to use to optimize the value extraction of resources from those batteries. Supposedly, if you are under a single umbrella, the technical issues can be handled more appropriately. What they are auctioning is capacity, battery capacity. They are not auctioning a particular service, not auctioning megawatt hours. Then you have a possibility of auctioning ancillary services. There is a full range of ancillary services, but I think the most interesting example is in Australia, where the system needs ancillary services to match distant loads with consumer centers for a growing number of renewable projects. You have, as I mentioned before, India running auctions for delivery of megawatt hours during peak loads, and that requires a hybrid storage and renewable combination. In some cases, countries say, no, it's technology agnostic, such as France said. But they set a cap on emissions. For example, in France, the auction run this year, the cap was 200 grams per kilowatt hour. The Chilean example, as I mentioned before, time differentiated supply blocks in Chile in 2019. So depending on the time differentiation, the bidder may or may not have incentives for introducing batteries to produce or to have the possibility of running price arbitrage. Colombia in 2020 also used this megawatt hour profiled, but batteries were not allowed to participate. And in the last two examples, we have semi-dispatchable and firm power, where batteries support renewables only or combinations of renewables and thermal generation. So in the case of Roraima in Brazil, one of the bidders proposed, it's not obliged to, but proposed to have a combination of batteries with palm oil thermal generation and the PV. And the batteries, it was 30-minute battery capacity, was just to provide a smoother integration between the variability of the solar and the optimal use of the palm oil resources and reduced fuel. So you can see it varies a lot. One interesting point in this analysis is that in most of the cases, not in all of the cases, because if it's a standalone resource, it's a value stacking service. We don't know exactly what the battery is going to be used for and which kind of energy is going to be used for recharging the batteries. But I would say in most of the cases, those examples help green the grid and help pave the road for an expansion of renewable resources, either by making the grid more resilient or by supporting the development of renewables per se, or by setting caps on emissions, or by better matching the needs of supply and demand. Anyway, batteries play a very important role in different shapes or form of paving the road for the growing penetration of renewables. Next, please. Okay, I think this is my last slide. One issue that we discussed was how to optimize value stacking. As I said before, in the renewable space, auctions were basically for one product, so that was relatively easy. But now, if we run auctions for just one product, we are afraid that these BESS, the assets are going to sit idle and not produce the full capacity of the full range of services they could provide. So of course, the cost will be higher because the asset is not going to be optimized. So there are ways of handling this. One is, I mentioned before, having the utility running, owning and maintaining the show and deciding about the state of charge. The second option is a similar arrangement where instead of the utility owning those assets, they can go into a BOT type of contract where you have a third party providing services, but the utility will decide about how to operate those. Of course, respecting guarantee issues, but they decide about the state of charge. And the compensation is usually for capacity made available. One interesting example, but it requires sophisticated markets, we saw in Australia where there was an auction for one particular ancillary services, frequency regulation, but the asset owner was able to sell arbitrage services or provide other ancillary services in other market. As I said, this requires market sophistication. Markets take care of it. And in many cases, the owner made more money selling products outside of the auction than the auction per se. And the other possibility we think it's yet to be explored is to have tenders involving multiple services in a kind of combinatorial type of auction. We didn't find any examples of it. The closer example we found was the 3 tariff blocks in Chile where bidders bid a combination of energy over those 3 time periods, and the auctioneer chooses the best options based on optimization algorithm on the prices and on the bids made. This was the closest we could find in combinatorial auctions, but we believe it's an issue to be explored. Combinatorial auctions have been used in many industries, but not yet in the renewable and battery space. So now I'll give the podium to my colleague Pablo, who is going to talk about general findings and recommendations from the study.
Thanks, Luis. I will take the virtual podium. I would like to summarize some of the key findings and recommendations from our study now. First, government agencies and utilities, we think, need to modify the rules, the procedures, and the rate provisions and auctions to provide a competitively level playing field for bids that include BESS, as this is still not the case in most developing countries. Second, auction rules and requirements should not limit the eligibility and competitiveness of bids that include BESS, either as a standalone resource or a combination with other resources. Auctions should generally be technology neutral and allow bids for standalone BESS or co-located or hybrid systems. Auctions that allow higher prices or scoring based on domestic content can actually deter investments in BESS. Third, policymakers should consider auctioning contracts with different levels of firmness to meet the specific needs of the power system. In fact, there's an international trend towards transferring part of the renewable variability risk away from buyers to sellers. And the regulatory framework and procurement and market rules should give sellers the necessary flexibility to manage those variability risks. Fourth, the ability to charge for the multiple services that BESS can provide, which is called value stacking, is very important to investment returns. This includes other services for the grid or large users in addition to firm power, as described. And although the costs of BESS have fallen and will continue to fall, the financial viability of the investments may still depend on the ability to stack multiple services. At this point, however, there are no industry standards or markets for pricing all BESS services, especially in developing countries. Fifth, the various business models that Luis described can be used for front-of-meter BESS in auctions. Those models may require different product specifications, rules, price, non-price award criteria. We identified 7 business models ranging from BESS as a standalone resource to provision of firm capacity and associated power generation by paired renewables with BESS. And those are detailed much more extensively in the report. And lastly, as the market for BESS matures, more sophisticated auction designs can facilitate competition and innovation and expand the range of products and services provided, including the introduction of markets for ancillary services. So, like I said, those are some of the findings, and there's much more in the report, which includes really a wealth of information that I invite you to look at more carefully. So, before some of you drop off, I want to make sure that you know the report is available online, and the webinar recording will be shared. And here's the contact information for our panelists. So next slide. We're a little behind, but I do want to pose a few questions, and I hope you will be able to stay with us for a few extra minutes. We received some of them through the pre-registration and in the chat. So for our first question, one of the attendees asked, what can be done to reorient the thinking of policymakers and energy regulators? Right now in markets like the Philippines, BESS is being treated as a generator, which does not fully capture the services that BESS can provide. And I think this question maybe gets at a few different things. One is the stakeholder engagement process to explore all the ways in which storage can meet the needs of the power system. 2, the task of comparing the costs and benefits of BESS against other alternatives. And 3, the policies and the market pricing regulations that are needed to enable BESS to compete with other technologies, as was the case with FERC Order 841 in the United States. So let me just turn this question over to our panelists, if you can comment on any of these in terms of reorienting the thinking of policymakers and energy regulators to really bring out the value of the multiple services that BESS can provide.
Hi, Pablo. This is Pat. to use the model for demand side management when policymakers were trying to implement energy efficiency programs back several years ago, or probably 20 years ago now. As those projects were developed, as those programs were developed, basically the regulators established what they call collaboratives, and the collaboratives were meetings of the proponents of energy efficiency, the utilities, the regulators, legislative government, people who would kind of implement the rules and regulations. And I think the collaborative was one of the important steps that kind of refined the rules and the cost effectiveness tests and all the other variables that are required to establish a solid DSM program. And I think kind of that model can be followed for implementing BESS programs as well.
And Andrew, do you want to add to that?
Yeah, I'd also add, I mean, I think Hawaii, the regulator in Hawaii has some very interesting thoughts on sort of how storage should be integrated into the market. I'd also say in the US case, Walmart has been looking at BESS in terms of sort of both demand side management, energy arbitrage that Patrick just mentioned, as well as sort of how to manage their DPV installations on their buildings. So I think there's a lot of options. I think currently reserve capacity and ancillary services such as frequency regulation are probably the best application for BESS at the current cost point.
Luis, is there anything you'd like to add? You're muted.
No, not for the time being. Thank you.
Okay. There's another question here, which I think is pretty interesting. It says, should renewable energy auctions include greenhouse gas emissions and air pollution emissions in the award criteria? And, there's, I think, a lot in this question. Should they do so? Could they do so? I think we have an example in France where there's a requirement, an auction where there's a requirement for to bid in for technologies with threshold for CO2 emissions. So I think maybe, Luis, you have best views on this.
Okay, thanks, Pablo. Yes, actually, we thought about this issue, we debated internally. For the time being, our paper does not include anything in this regard, but it should. And if in subsequent papers, maybe we could. The difficulty is how to do it. Many of those benefits are very difficult to quantify. For example, ancillary services, if someone runs an auction for BESS services, you don't know exactly how those services will be used, which energy will be used to recharge the batteries. There are cases where the benefits can be quantifiable. For example, when India runs an auction for peak power, we know that it will be displacing thermal generation, so it's easily quantified, at least as far as the abatement of greenhouse gases are concerned. On pollution, let's say particulates, SOx, NOx, it's much more difficult to quantify. I'm not saying it's easy to quantify greenhouse gases, but at least we have some markets in the world, we have some projections on how greenhouse gases prices are going to evolve. So there are different prices, but we can do some rough estimations. So the issue, I think the question, Pablo, is how we could potentially incorporate this into auctions. One way is in those price and non-price factor kind of auctions, the ones normally run in the US, we could include one of those elements like environmental issues, greenhouse gas emissions. Actually, if you look at PURPA, the Public Utility Regulatory Act back in the 70s, late 70s, in the last versions, they were running auctions and some of the weights were related to environmental issues. So that's one way of approaching the problem. The second way is to say, okay, let's run an auction, and the award price will be based on greenhouse gas abated and the price of the megawatt hour being bid. So it's a combination of different things in monetary terms. It could. Pollution would be, as I said, more difficult. As Pablo said, we can run a technology agnostic auction, but set a cap on emission, like France. France into 2020 in the capacity auction, they said no more than 200 grams per kilowatt hour. Therefore, there is no way to include not even the cleanest thermal generation, which was natural gas. It was out. It was only batteries, PV, and demand response. There are situations where we don't include greenhouse gases in the auction for energy, but we treat it separately, such as Mexico and in China. They have auctions for greenhouse gases, for green certificates, separate from the energy. It's a renewable energy certificate, which is another product in the market. One renewable energy certificate is equivalent to 1 megawatt hour, for example. It's one way of doing it. I'm not saying it's simple, but it's one way of doing it. In the US, there is a long-standing tradition of a greenhouse gas market. I think the first cap and trade was implemented in the mid-Atlantic and northeast US, the so-called RGGI. It's RGGI, but it's a market among utilities. Even though it's voluntary, once you adhere, you have to abide by it. Where utilities have quotas, they can trade quotas in a kind of cap and trade system, but they have an obligation to reduce their greenhouse gas emissions. It's another way. So, in summary, we can incorporate into the auctions where we can treat it separately as part of a greenhouse gas auction or green certificate or quotas or so forth. But for the time being, the jury is still out. We don't have any position on this, and we didn't analyze this in depth.
Thank you very much, Luis, for that excellent overview of the issue. We are a little bit behind schedule. There were some other questions that we didn't get to. I know there's some in the chat, some that came in that were country specific. And I want to make sure to encourage you to look at the report, because we did cover a lot of country specific examples, such as South Africa and India, for example, which participants were asking about. And I think we'll also see what we can do to help answer some of these questions in our webinar follow-up. I think we've reached the end of our allotted time. There was a lot of rich material, and I want to thank all the participants for joining us, and a special thanks to our guest, Andrew Fang from USA, and to Seek for hosting our webinar today. And to say, stay tuned to our upcoming 3 other webinars from CEDAR. One of them is on December 10th on the preparation of distributed energy resource roadmaps or plans. So very related, very relevant. Again, thanks very much, and we hope to see you next time. Thank you. For our panelists, I think we're going to wait for everybody to leave the room, and we're going to have a short